Now let's take a peek at the median average. Because up here we noticed that there was this 20, and maybe that had a really big say in Big Back Barbecues having a wait time that was longer than Betty's. So let's take a look at the median average. And to me, this is the number that splits the data into a low half and a high half. It's the middle value. So this is the number that splits the data into a low half and a high half. So I really do like to think of it as the exact middle value of the data set, splitting it into the low and to the high. Not to give any negative connotation to low versus high and positive for high, because there are a lot of times when we want low numbers. For instance, in wait time, or in there are just many times when a low number is good, like low error is nice. And there are some instances when a high number is nice. So I just don't want you to have that connotation. It really is just taking a data set and splitting it into the low half and into the high half. Some remarks. In order to split it into a low half and a high half, you always have to order the data from low to high. So the data set must be put in order from low to high to find this middle value, 2. And lucky for us, quantitative number or numerical measurements can be ordered from low to high as opposed to qualitative ones. Okay, another remarkable thing about the median is that it's just another average, and it pays more attention to the middle than to the extremes. So I'm going to jot that down. I feel like that's why it was created, is because it's another average, but it pays more attention just to the middle than to the highs and to the lows, the extreme highs and lows. So the median is another average I'm actually going to use the word more, that pays more attention to the middle than to the extremes. Okay, and so a lot of people, when they say average, some mean the mean average added up and divide, and some actually, when they say the word average, are talking about this middle value, the median. For instance, when they say the average home value, or the average income, all of those are referring to middle values because they pay more attention to the middle than to the extremes. So it is used quite a bit. The median is called sometimes, so it doesn't have a symbol, but it is called MED, or sometimes it's referred to as Q2 for the second quarter, where Q stands for quarters. Let's write that down. So 25% plus 25% makes 50%, or half. So bringing it back, number that splits the data into the low half and the high half. First quarter is the lowest. Second quarter is the, second 25% of the, so it's still on the low half, but it's higher than the first quarter. And then those two quarters together, so those two quarters make 50% or half of the data. So it would split up and find the median is the middle, and it would find that second quarter there. And then my last remark about the median, is that data sets may or may not include the actual median numerical values. So data sets I write at an incline. And here's what I mean. For example, let's suppose I have a data set and it is 1, 1, 2, and 2. Then the median for this data set here's the split that cuts it into the low half and the high half. And here the median is 1.5. Exactly in between this 1 and this 2 is 1.5, and that would split this data set into the low half and to the high half. And as opposed to a data set that looks like this, 1, 1, 1, 2, 2, for this one, the middle number here is 1. That's our median, and it is splitting the data set into the low 50% and to the high 50%. So the median here is 1. So sometimes it's included in the data set and sometimes it's not, in order to split it into low half, high half. So just as I mentioned there. Okay, let's compute. So let's use the Big Back Barbecue again. And it says rewrite the wait times at Big Back Barbecue in order from least to greatest. Okay. I just put that on the floor, so I better bring it up here. Okay. Big Back Barbecue in order from least to greatest. On it. 1, and then it looks like 3, 4, 5, 5. 3, 4, 5, 5. So 2 people waited 5 minutes. 2 people waited 6 minutes. 1 person waited 7 minutes. 1 person waited 8 minutes. And then that 20-minute waiter. Ooh. Did we get them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we got them all. Find the median of the data set for Big Back Barbecue wait times. Okay, so immediately a lot of my students will do this. So, okay, let's find the middle. So scooting forward 1 apiece, the middle appears to be right here. So that cuts it into the lower 5 wait times and the high 5 wait times. So it looks like the median here is right in the middle of 5 and 6. So, and in case you're like, how am I going to find the middle of 2 numbers? So the median is 5.5 minutes. And just to write down how I figured that out, I really added these two and found the average. So the perfect middle between 5 and 6 is 5.5, and You find that by taking the mean average of those two. That's funny. So exactly in the middle of 5 and 6 is 5.5 minutes, and that split it into low 50 into the high 50 wait times. What is the meaning of this in the context of the situation? Okay, so this is going to be strange. On average, the patrons wait 5.5 minutes before, getting served at Big Back Barbecue. Okay, which the reason why I feel like that's so strange is that if we look back, this sentence said, on average, a patron at Big Back Barbecue waited 6.5 minutes. And now this sentence says, on average, the patrons wait 5.5 minutes before getting served at Big Back Barbecue. So all of a sudden, this word average, it's the same sentence, except this number is different than the other number. And this is still a measure for center, so we can still call it an average. But they are different numbers. 5.5 minutes wait time versus 6.5 minutes for the mean average. So it matters. And if we're vague about it and we just say on average, we're not really indicating what kind of average we're using. And this happens a lot. Rewrite the wait times at Betty's Barbecue in order from least to greatest. Okay, let's do that. Okay, so 1, I see 2 2s and then a 3. Okay, 2 2s, a 3, a 4, a 5, a 6, 2 7s, a 4, a 5, a 6, 2 7s, an 8, and a 9. Okay, and there should be 11 of these, so I'm going to double check really quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Got them all. Let's find the middle. All right, so here are my two extremes. Okay, and then as I work my way to the middle, 5. Here's our middle, the median. Minutes. Got it. What is the meaning of this in the context of the situation? Very similar. So on average, a patron at Betty's Barbecue waited 5 minutes. Oops. Okay, and now I'd like to compare that to what happened before. So in example 3, let's talk about that. And I just said on average because this is all, the middle is a measure for center. It's a summary of this whole data. On average, they waited about 5 minutes. But now let's talk about this median versus this mean. So suppose instead of the longest wait time at Big Back Barbecue being 20 minutes, it had really been 2 minutes and somebody wrote it down wrong. Recalculate the mean average. Okay, so I'm going to go back to here. And we're redoing this, except that is now going to be a 2. Okay, so that means this number will change. Okay. let's do this. Okay, I have to jot this down. So 5, 8, and now instead of 20, it's a 2, 3, 4, 1, 5, 6. Oh, you know what? It's just so much easier to use this list now, especially because it's in order. Whatever. I went back to the original data set. But this should be, I mean, this is exactly the same one. And if we add those all up, 47 now. So now the mean average, if it were not 20 minutes and it really had been 2 minutes and somebody just accidentally wrote that 0 down, then really the average would have been 4.7 minutes. Was the mean the same or was it different due to the change? Mean definitely went down. The mean went down because the 20 became a 2 and it was added in, so it definitely went down. Recalculate the median average wait time at Big Back Barbecue with the correct data set. Okay, let's get to it. So I'm going to use my list from up here and rewrite it down here, but instead of the 20, it's a 2, so that's going to go down here. So then it would be 1, 2, 3. So this 20 had become a 2, sliding it over here. 1, 2, 3, 4, 5, and another 5, 2 6s, a 7, an 8, and a no longer a 20. So now here's our data set, and our job is to find the middle. Okay. In between 5 and 5. So here is the low 5 wait times and the high 5, the high 5 wait times. And that makes the middle exactly 5. Okay, recalculate the median average wait time. Median equals exactly 5 now. Was the median the same or was it different due to the change in that one data value? Well, up here it was a little different actually. So here the median was 5.5 because this 20 slid from the high half to the low half, making the median a little bit lower. It was different. Why did this happen? Because it slid from the high half to the low half. So, okay. The median went down. Okay, but not by much. So, and why did this happen? Because 20 moved from the high half to the low half. Okay, so just to make a quick comparison, with the 20, the mean average went from 6.5 down to 4.7 minutes. So just over 4.5, a 2-minute difference. And it might not seem like a lot, but I bet you to a business owner, it seems like a lot, like 2 minutes difference. But then when we look at the medians,